Hey, what is up, Chad? Good morning. Hey, everybody. How are we? I gotta move this over here so make sure I'm using the right camera. Welcome to the weekly VS Code live stream. Today we are doing TypeScript tips and tricks. This is going to be a great one. We have a great guest, and we know from the last stream that y'all hate small talk, so we won't do any of that. We'll just get right to it. Y'all welcome Matt Pocock to the stream. Matt, I actually saw Matt. You know how I found you is that somebody posted one of your tweets in the VS Code in our team Slack.
Oh, no way.
Yeah, and then I went and looked, and I noticed that Wes Boss called you the Rodney Mullen of TypeScript. Like, who is
like
this guy?
He's gonna live to regret that, because that was literally one quote tweet one time, and now I'm like, it's like in my bio. Everyone knows me as the Rodney Mullen. So.
Well, apparently you're famous. Mahmoud, do y'all know Matt? Are you famous? And I don't travel in TypeScript circles. Like, am I in the presence of greatness here and I just don't even know it?
TypeScript royalty, maybe from a small kingdom that I represent.
Awesome.
Well, hello, chat. It's nice to meet you.
Yeah, thank you. And thank you for being here, Matt. We appreciate it. We know that you probably have another job. We just assume that you do. Maybe you could just introduce yourself and tell a little bit about Matt.
I'm not a rambling TypeScript nomad. I am a developer advocate at Stately. So we make tools for handling state machines and for front-end development, back-end development, and exploding your dev experience into new heights. So not just TypeScript, but also state machines as well.
And how did you get into working with TypeScript? I mean, how does one go from being Matt the grade school lad to Matt the Rodney Mullen of TypeScript?
Yeah, well, it's kind of, I was working at an agency where we used JavaScript a lot, and kind of JavaScript was the first thing that I fell in love with coding, as most people do, making things on websites is all very cool. But we were working in a big team, and I was struggling with dealing with cross-team communication and all using the same components and everything getting all messed up, really. So I came to it through front-end land. And then working on the XState core team, which is where I've been for the last kind of year and a bit, it's been amazing for figuring out all the crazy types that libraries do as well, because open source world and actually open source libraries, they're just operating at a whole new level of sort of TypeScript stuff as well.
Yeah, so that is fantastic. I know today we talked about this prior, Chad. Believe it or not, we do plan these things. We don't just show up and wing it. I know it seems that way. It's not what we do. But we talked about doing some challenges. You got some challenges for us today, and we're going to walk through about 10 of them. And Chad, you have a unique opportunity to do this along with us today. So did I get that right? Is that what we're doing? What are we doing?
That's right. I have 10 TypeScript challenges for you. And this is going to test you in terms of especially your kind of advanced TypeScript. We're going to learn hopefully some concepts that you've never seen before in terms of TypeScript. And we're going to push it kind of as far as we can go using VS Code as kind of like our tool station, and it's going to give us loads of really cool inference. It's going to give us lots of nice warnings, and I think it's going to be fun.
All right, so before we dive into that, and we'll just burn a couple more minutes, wait for chat to show up. They want you to talk about Deno or Dino. I'm pretty sure it's Dino.
You know what? I don't know anything about Deno. I know that it's cool. I know that it's might be a sort of competitor to Node, and it's especially Netlify functions, I think, release edge functions, which are powered by Deno.
Yeah,
I know Remix is thinking about Demo as well, Deno. And yeah, so I have no opinions about Deno so far.
You have none? Not a single opinion about Dino?
I have a feeling. I'm very excited, but no strong opinions as yet.
Okay, so there you go. Matt's opinions on Deno. All right, well then, T-Leaf, I'm with you. I don't know much about TypeScript either, other than just :any seems to solve all of my problems. So with that, Matt, let's get your screen up. Let me add it here.
Cool.
Oh, sorry, Mark. I did that. And here we go.
All right. So I'm double screening, folks, by the way. So if I'm looking over at your right side, then I am looking at chat. So apologies for that. But here, who knows React? Spam in chat. Spam yes in chat if you use React, if you know it, if you've used it. We're going to start with a little bit of React here. And what we've got here is a table component, which is this little thing here. And how's the font size, by the way? Shall I bump it up, or are we all good? Or I think we're good.
I think it looks really good, yeah.
All right. So we have this table component. And this table component, like, I remember working in a repository where it was like, there was like 12 different table components for like, you would render like the to-dos in one table component, render the users in another table component. And I thought to myself, what if we had one table component to rule them all? Right? Oh yeah, chat is saying yes, use React. Okay, cool. I'm going to assume that you guys know the basics of React. And what if we had this one awesome table component that could handle any type of data that we threw at it? And that was my first foray into TypeScript, really. And what I would like you to do, chat, is we have prepared TypeScript playgrounds for all of these examples, by the way. So what we're going to do is we can send you the TypeScript link, I think, if we want.
Yeah, Mark, can you throw up that first AKA, that first challenge?
Let's do it. And you'll be able to try and solve this. So what we're going to try and do is take this ID string here, which kind of represents our sort of like the thing that we want to pass into the table component. Like this could be a user. So we could say first name string, last name string, etc., that sort of thing. And we want to make this generic. So if you can, go into chat and repost your links back in. We may take a look at them if some of them are pretty good. And for now, I'm going to try and solve this on stream. So how do we make this generic? Well, we first need to assign a generic into this table component to say, whatever we have here, whatever we pass to the table component, we need it to be sort of like something where we need to kind of hack into TypeScript's inference a bit. So here, I'm going to add a little T item here. And actually, I'm going to add a little comma on the end just so it sort of formats correctly. So we've got this T item. Now, in TypeScript, this generic syntax here, it's basically saying, okay, TypeScript, I want to know what that T item is so that I can then manipulate it and do stuff with it. We're going to need to pass that T item, it's kind of like a variable, into table props here. And we're going to grab it there too. So now we can replace this ID first name here with T item and render item here, which is kind of like the instruction that we're going to use to sort of say, okay, let's render the item out. That's also going to take a T item. So what does this mean? This is kind of like some mystery syntax we have here, like everything seems to have disappeared and now there's T item everywhere. What's happening is that now when we pass items to the table, we can now pass anything into here. So first name, Burkle, and
works.
Render item now picks up what we've passed to the table. So we can now say, okay, we can pass anything into here. And so let's say we've got a table for our users. Add a little React fragment here too. And let's say we've got a table for our pets. So I've got my cat Bandit is just kind of sat beneath me right now. And so we've got one for the people that we know and one for our pets that we know, for instance. And they're both inferred differently. So this generic component can now be used to represent a table of any elements. Pretty cool.
That is really neat. But question, why not just use a plain object? Would TypeScript just not allow you to do that?
Yeah, let's try it. So if you use a plain object, if you just like remove this generic, let's say, and let's say we just pass in like a plain object here, it then means that you would have like an empty thing here. So this item wouldn't be inferred properly. So you wouldn't have like item.id or item.whatever because it says it doesn't exist.
Yeah.
So if we then put that back with T item just here, we now have, oh yeah, I need to add the generic back in. T item, comma, whoop. God, it's getting all funky. Here we go. Now it's failing because it doesn't exist on type ID string, first name string.
Gotcha. So you're getting the type checking down there in the JSX. So T item basically allows you to create strongly typed objects on the fly?
Exactly. You're basically saying to TypeScript, I want to know what gets passed in here so that I can also have that same thing here. And that's what's going on up there. We say T item is this little slot where I say, what is this? And then we say, okay, it's recognized here. And so it's also recognized there.
Very cool. That I didn't know you could do that. Chat, did you know that? I didn't know.
Yeah. What do we think, chat? Anyone got any replies to this? Anyone come up with some solutions? Or shall we move on to our second one? Or anyone got any questions about this too, or anything they want to see?
Questions about T item?
Yeah, questions about generics in general. This is kind of the generic section of the TypeScript docs. Isn't scon a T item? Bloody Eric, man. He's always in every live stream I do.
Isn't a scone a T item?
I mean, we could have a scone.
A T item, a scone.
Oh man, that's terrible. That is terrible.
Eric, thank you. And at the same time, how dare you? Okay, all right. Are we ready to move on to the second? I actually like that joke. Are we ready?
That's pretty good. Yeah.
All right.
Let's do number 2.
There we go.
So here we have, this is no longer React stuff. This is now just pure TypeScript, like a utility function. And what we're trying to do, the challenge here, is to make this function be able to look into any sort of object here. And then basically we want it to be able to grab the correct value type from inside this object. Because what we want to say is we want to say, okay, foo a, that should return true, or a Boolean type, you know. And this one here, b2, if we say b here, then this one should be typed as a number. So we should be able to say type of value equals number, and it should work. But currently it's typed as any, because we've been sort of a little bit lazy and we haven't managed to type this properly. And this is quite hard to type. So we're going to need to use a similar approach to what we had last time, because you can pass any old value into here. And just the same as in the previous section, we need to say, okay, TypeScript, what is the type of this? So that we can properly type the rest of it. So we'll start with that. We'll start with a obj, or t-obj. And this, by the way, this t prefix is just like a sort of convention that we use in TypeScript. And we're now saying that obj should be passed as t-obj. Okay, so we're starting to get an error up there, but we're going to ignore that for now. One thing that you can do in VS Code when you're using TypeScript is you can actually hover over any function, and you can actually see the generics that are getting passed to that function. So here we can see that foo, a Boolean, b number, bar cd. Oh, that's the object that we're passing in. If we put in a different object, we can put in like foo a, for instance. And if we hover over this, you'll see that foo string is getting computed there. So you can actually see all the generics in there, which is very, very neat. So if I revert that, we now need to work out this error. So no index signature with a parameter of type string was found on type unknown. Okay, we have our first kind of cryptic TypeScript error message to deal with. This one is kind of about, no index signature with a parameter of type string was found on type unknown. Well, this is getting computed as type unknown, and we're trying to say, okay, first key here, it's basically saying we can't index this, we can't access it using string because we don't know what it is. All right, the way we do that is we can say key of t-obj. Yeah. So this means we have key of t-obj, and we're starting to get a bit more inference here. This little foo just here is now typed as bar or foo because it's looking at the keys of the objects that we get from the generics, and we sort of like can look at them. But we've got to go even deeper here, actually, which is we need to access the second key based on what the first key was. So we need to ask TypeScript, what is the first key? And this is going to be here, t first key. And t first key is actually, we can actually restrict the type of generic that gets passed in here by saying extends. So t first key extends key of t-obj. So this is kind of, you can see how the syntax just kind of explodes at you and like looks kind of pretty complicated, really. There's a cool couple of questions here. Like Fictive asked, does anyone know why specifically the letter T is actually used as a convention in different languages? Type. Do I have the power to click that and put it on the screen? I don't know.
Sorry, yeah, I got some additional noise here at the house. Which one is Which one are you?
413. Does anyone know why specifically the T is actually used as a
Oh,
convention?
yeah, this one here. I'm going to shut my office doors, Chad. I'm not leaving.
No worries. You're in my capable hands. Let's take over this. So yeah, T, I guess it's just type, I guess. I don't actually know why it's a convention, but yeah.
I never thought about that. But I got some T questions, Matt, and that is like, what is the difference between T object and T item? Because we just did T, this seems like the same thing.
Yeah, it's the same thing. It really is. So this is just like a name of a variable that I have here. So I could call this T item if I wanted.
Oh,
this is like
so that's not a TypeScript thing. That's not a construct. That's just the name you're giving it.
Just the name I'm giving it. I'm saying this is a slot that I want to look into and understand, and I get to name it. So here, T first key, I could say this T Burke or whatever.
Okay.
It's just like a named slot, basically, like a variable, really. And here, then, we're getting pretty far. We've got the object that's being passed in, and we've also got the key of that object that we've chosen now selected in the generics too. And finally, what we want to do is we want to say T second key extends key of T obj, and then look into that and say T first key. So this is kind of wild what we've got going on here.
So why is it not T second key extends key of just T first key? Why does it need to be T obj and then array syntax?
Yeah, because we're basically saying, okay, we want object.foo. That's kind of like what we've accessed first. And then we say, okay, we now want to get the key of object.foo. So this is kind of like accessing.
Oh, gotcha. Yeah. So that's the property accessor, the array syntax for, okay.
Exactly, which is special to TypeScript as well. It's sort of slightly different from the JavaScript version, because in JavaScript, you would say TObject.firstKey, like that.
Right, or you could use the array syntax, but you'd have to quote it, right?
Exactly, yeah. And I guess you can actually do that in TypeScript too. You can say object like const foo equals foo, and then const a equals obj foo, like this. Right. So it's kind of like this syntax, basically. So now if I add that back, we can now see that we have foo and b here. So if I change this to bar, then this is going to start erroring because it's not assignable to type C and D. This is another sort of like, I really wish TypeScript like cleaned up its errors, like not assignable to parameter, kind of like, it feels like it should be like, you can't have B here, just put C or D,
Yeah,
like,
but Matt, the errors are what make us so smart, right? So that when other people see that, they're like, how do you do what you do? Look at that.
They are not assignable to parameter. Yeah. It's oh man, like Rust has like beautiful error syntax and stuff, but like,
does it really? Does it tell you?
Yeah, I've heard that. I mean, I'm not a huge Rust user, but yeah, it's like it shows you exactly where it is and like shows you exactly what's changed. It's gorgeous. Nice. But here then we're finally getting, so we now have it properly typed so that the value is a number. So it's bar D, which is a number. And if we change this now, value is a string. So finally, having sort of gone through all the generic layers, we now have a function that does what we wanted it to, gives us perfect inference, and works beautifully. So you can have, essentially the lesson from this, you can have more than one generic, and they can rely off each other. So one generic can depend on another.
Okay, so if you were looking for the value of foo b, then it would become a number, correct?
Exactly. So foo b, and value is a number.
That is crazy. So I got a question for you, Matt. Would you recommend then that when using TypeScript that everything should be typed? In other words, if you find yourself in a situation where it doesn't know what the type is, or it's just any, you've done something wrong?
So yeah, I mean, it's tricky because a lot of these like really complicated types, they belong in library land. Like ideally, you shouldn't have to worry about writing this stuff unless you're either writing a library for other people on your team to use, or you're consuming it, or you're writing a library, to go in NPM or whatever. So when you come across something that isn't typed, like let's say, if I just go all the way down here and say const, or like something that's been typed badly, or typed with any. So const func is like value equals any,
right?
And then like does something. So in here, probably this is like, it's either a cry for help. Well, it's a cry for help, definitely, right? It's like, TypeScript, why?
Just let me live my life. Yeah.
Let me live my life. Or the person who's done this doesn't know how to express this complicated syntax to do what they want it to do, which is fair enough because it's kind of wild, this stuff. But ideally, you should, let's say, like, imagine there's a value which, like, this is like a really simple example, but it shows how hard it is to type something in TypeScript sometimes. So imagine if it's just like return what I pass in, right? And so the value is any, and you just return the value. So let's imagine now, how do you actually type this without using any? Do you do like string or number or object or any array?
I mean, that's probably what I would do that. Yeah.
Yeah. But then when you do that, it's not returning exactly what you pass in. It returns string or number or object or any.
It could be any of those things.
It could be any of those things. So it's not actually returning what you pass it in. Whereas the simplest use case I can think of for generics is you just say tval here, and then you add tval. And now you've basically said to TypeScript, okay, whatever value gets passed in, that's what gets returned. So like const result equals return what I pass in, A, for instance. And that is now typed as A.
Very cool. Okay, that makes sense. Chat here, let's see. So this is, we're going to move on to 3, y'all. Maybe we may only get through 5 of these today, man. That's okay.
Yeah, that's fine.
Ibrahim said, let's say the object is from an API response. Do I need to explicitly write the API response type? I find myself with this question all the time.
Mm-hmm. Yeah, this is a really good question. Actually, I'm going to go on a little diversion and show you a library which is amazing for this. When you're at the edges of your application, let's say you're getting some data from an application that you don't trust or that is not in your control or is like a third-party API. The question is like, do I need to go and let me actually just create a new thing here. So whatever.ts. The question is like, okay, I fetch something from somewhere and I go something and then res.json. And this result in here, how do I type this? Okay, because that's going to be any, right? It could be anything that you fetch there.
Right.
So how do we get this result? Well, if you have something that's not under your control, then you probably should be validating it at runtime. And you can actually use a library for that called Zod. And I'm going to show off Zod a little bit. So I'm importing Z from Zod. And imagine that I've got like an API response like const data equals z.object. And you might have used something like this before. Let's say id z.string, name z.string. And what we're going to do is we're basically going to go const data equals data.pass result. What this does is it basically says, okay, this is the thing that this is the shape that you expect it in. And now then, if you need to use that as a type, like Zod is so cool because you can go const type data type, let's say, equals z.infer type of data. And so this data type, you can now just use that in your application. So what this does is it checks it's okay at runtime. And it also gives you like the type constructs and stuff you need to be able to verify it on the type level as well.
Okay. So the data, dismiss that quick bit. Yeah, so the data. Okay, so data is the Zod object, and that's why you're passing the parse, and that's where it's going to infer the type right there.
Exactly. Yeah. Okay. So what this does is it errors if it's not exactly this type.
What happens if you don't have? Like, is it possible? Will Zod infer types without you specifying it first, like you did there in the data object? In other words, if you pulled that out completely and just said data type and have it infer, will it automatically infer from the JSON? Because JSON can only contain strings, numbers, dates, which would be strings.
So like, because that information needs to live somewhere in your application, So you could say, like, one way to do it is just to write all this down, right? To just say type. data from API equals, or I should probably use an interface there. ID is a string, name string.
Yeah,
and this is okay.
What I normally do is create the interface. Yeah.
Yeah, exactly. But this doesn't give you any runtime protection. It just sort of says like, okay, this we're basically, what you would have to do is say result is this shape.
Right.
Which is kind of the normal way of doing it. But if you use Zod, you actually get kind of runtime protection, and you can use this data type to infer it later as well, which is, so you get best of both worlds.
So what if, this is a good question, what if the parse fails because the definition has changed?
Yeah, so that may result in an error in your application. You know what I mean? So if the definition has changed, then like, if the API changes on the end, then it's going to throw an error in your app. And it's probably better to catch those errors early than it is to just sort of let them propagate through and let your app get into an impossible state.
Huh. Will it be a cryptic error like type of B not found on unknown?
Zod actually writes its own errors, and they're always really sexy and really nice.
All right. Let's move on to let's move on to challenge 3.
Yep.
We got so many. What do you want to do, Matt? You want to move on, or we got a lot of questions here?
We've got a lot of questions. I mean, I'm happy to like treat this pretty loosely and take some more questions if we think.
All right, let's do a couple more. Why interface over type? What are the use cases for an interface?
So there are some really, really complicated reasons why you should use interface over type when you can. I don't know how to explain them that well without using really complicated language. So probably what I'll say is use interface for most things. Like this interface here, interfaces can express a lot of different things, except for they can't express things like type my string equals string. So in general use, you won't notice the difference between interfaces and interfaces and types. So I would just say use whatever you feel comfortable with. Like the reason that a lot of people use interfaces over types is because there's like a really popular lint rule that tells them to. And it feels a bit like when React Airbnb thing came out and everyone was like fighting over these weird lint rules. Like it doesn't matter too much, basically.
Okay, so it's a stylistic choice. Although I feel like canonically speaking, most things are interfaces, not types. To me, a type is like, I want to define a new data structure. That's a type.
Mm-hmm.
An API response would be an interface. Or in the case of Zod, whatever Zod does too.
Yeah, it's basically, it's like an alias, essentially. So it's just saying, this thing here, I'm going to give it a name. It's essentially that's all it does really. Whereas an interface does a couple of other things, like an interfaces can mainly only be objects as well. So you can express like complicated stuff in here. Like I think you can do like function calls inside here. Maybe I'm getting that wrong. I don't know. I can't remember the syntax for it basically. But I generally mostly just use types and use interfaces for plain objects as we have here.
Gotcha. Okay. That's the official guidance from Matt. All right, let's do 3. Let's do number 3.
Let's do 3.
Learn some more TypeScript.
All right. So here you can do if-else logic in TypeScript, which is kind of crazy. TypeScript is Turing complete, actually, so you can do all sorts of crazy processing in it and all sorts of wild stuff. And it all comes from the ability to conditionally do stuff. So here we have an animal at the top, and then we have a human. And we have get required information, T-type, and currently that's typed as any. And here, these are both typed as any, because we're trying to get the required information for an animal and required information for a human kind of through this type here. And you can think of this type as kind of like a function, and this is the argument to the function.
Okay.
And what we're going to do is, for a human, we need to be able to get their, let's say, social security number. And for an animal, we need to get their age. Okay. So there are different fields that we need to get for both. And so my challenge to you is how do we do that? So what you can do is you can say T-type extends animal. And if it does extend animal, we're going to return an object with age in there, which is a number. If it doesn't, we're going to return social security. Oh God. Number, which is a string, I guess. So here you've actually got this kind of ternary syntax where we're saying this extends is kind of like an if. So if I were to write this in JavaScript, it would be something like if t-type, like, I don't know, instance of animal.
And yeah, what type is it? Then do this.
Exactly. Then return age, 12 or whatever. Otherwise, return, else, social security number. The idea.
Wait. Neither age nor social security number are on your animal and human objects.
Correct. Yeah. So this is basically all it's doing is it's checking if it's an animal and then returning one thing.
Okay.
And then if it's not an animal, it returns another thing. So it's just totally like the only reference to human and animal is here in this function. And so what you get is required information for animal, age, number, required information for human, social security number.
Wow, very neat.
It's so crazy. And you can do all sorts of stuff with this. Like this is just the simplest case you can imagine. So you can even like nest these. So you can say t-type equals animal, return the age, or let's see, t-type extends human, then return the social security number. Otherwise, return, let's say, I don't know, one thing that you generally return when you're sort of like, you've reached a case that is illegal is you return never. And so this is a way of telling TypeScript, okay, this should never be reached. And this sort of like, whenever this gets reached, you get some errors here. So
never throws an error?
It sort of throws an error. Basically, if you try to use it anywhere, it's like, it's not really assignable to anything, essentially. So you'll get errors.
I've never seen the keyword never for TypeScript. This is the first time.
Wild, yeah. So required information for alien. Let's say get required information, and we're going to pass in, I don't know, planet, string. And so required information for alien is now typed as never. So, and if I try to,
it's not a human and it's not an animal, therefore it's never.
So if it were an animal, then we'd return age. If it were a human, return social security number. Whereas if it returns t-type extends planet string, then we'll return, I don't know, why are you here? String. Otherwise, we'll return never again. So again, you can just nest these and nest these and nest these. And so here now, this is going to be why are you here?
Yeah, and except in that case, you didn't have an existing type. You just made one on the fly.
Yeah, exactly. So this is just a sort of on the fly planet string, and you don't need, so this human here could just be another first name string, or in fact, I think this might even work. It could even be a partial here. Let me check that. Yeah, so it doesn't need to be the entire type, madly enough. But you can use anything here, like this is just a type instantiation, so it could be a string, could be a number, could be whatever you like.
My gosh. So this generic, so I'm learning that you can basically do anything with generics. That's what we take away from this.
It's wild. Yeah. It's wild. Like, so it's just a way of asking TypeScript, I want to hack into your inference and I want to manipulate it any way I like and transform it, do all sorts of crazy stuff.
That is extremely powerful, but what if you get I just feel like I would get the syntax wrong. Like I watch you do it, it looks easy, but I'm just going to forget that I need an extends or that, I'm missing I'm missing a type, something like that.
Yeah. There's like, it's relatively few primitives. That's the kind of impressive thing. It's like not that many things that you need to be able to do in order to get it all working. Like really, like you've got like a variable declaration here. You've got like an if-else statement. You've got like basically like a throw error here. And you've got like, this is essentially like a function, this here, and that's calling the function. So it's different syntax, but it's like relatively simple primitives when you get your head around it.
All right, let's see. Ruben's asking, can we have a use case for those kinds of types?
Yep.
Where we can use it?
Great idea. We could go to a different one for this, actually.
Yeah, let's do that.
Yeah, we could jump ahead all the way. I imagine we're not going to get up to all 10 of these because
No.
we've already run over, right?
We'll have to have you back for another 5. Yeah,
yeah, exactly. So like, let's do this one, which is, we have here a function which basically says we want to deep equal compare something. And we're using this little kind of triple equals here. So this is number 9, by the way, Mark. So these triple equals are basically saying, okay, this should deep equal this. Except this isn't going to work with arrays, because arrays are, if you do this equals this, they're never going to be, it's never going to return true, basically, because if you compare 2 arrays like that, it's always going to return false. So we've added this kind of like throw new error if you want to compare the 2 arrays. So what we can do is we can actually move this into the type level by adding a conditional check up here. So we can say arg extends any. We can say don't pass an array. Otherwise, we're going to just return. We're going to return arg here. So this means that when we come to use it, if we just add like 2 strings, A, B, then it's fine. Whereas if we add an array, so array, it's going to say is not assignable to parameter of type don't pass an array. So you can actually throw these like error messages using these conditional types. And it means that we can actually just remove this runtime code because we've moved it into the type level.
So then it'll throw an error. Not only does it throw an error because you passed an array, but instead of getting a cryptic message, you're actually telling people a descriptive, don't pass an array.
Exactly, yeah. So you actually get to improve on TypeScript error messages here by adding your own.
Man, that is so cool. I mean, it's just so much less code. It's so terse.
Exactly. Really, really neat.
I like it. All right. Julio wants to know when your TypeScript course is going to be available. You got one coming?
Yeah, I've got an advanced TypeScript course coming out, hopefully this year. It's at mattpocock.com, and you can check it out. It's going to be like diving into all this stuff really in depth and focusing on kind of library code and what people do there and like looking at all this cool stuff really. And I'm trying to make it as complete as possible because there really isn't that much like advanced TypeScript stuff out there. Hopefully, let's say this summer to this autumn, because there's a lot of content to record and I've still got a full-time job.
All right, let's see. Can you maybe explain, hold on, let's see here. Can you maybe explain the in keyword a bit? It's something that's been quite confusing to me. Not the JS in keyword, but the TS type systems.
In keyword.
In.
So the in keyword is useful for like when you have const, okay, let's imagine you have a function here. So const func equals, like, let's imagine that we really, really, really don't know what's going to be passed into here. Like, so we'll go value equals unknown. And what we get to do here is we can say if val, and let's say there's a property called like, so we basically want to check that it's an object. If we say that it's got like a name in val, let's see, object is of type unknown. So probably what we want to do is if type of val equals object and name in val, then object is possibly null. Oh yeah, this is crazy TypeScript's inference, by the way, because it knows about that famous JavaScript bug where if you say val equals object, like null will be counted as an object. So we need to check that val is really there. And now we know that val is an object, and we also probably know that val.name exists as well. So TypeScript is a little bit funny there, but we could, let's say we know it's kind of like either going to be a name string or age number. So here we can pass in either name string or age number. We now know, we can actually remove all this stuff too. We now know that val is name string because we checked the name in val here. So this basically is like a little shortcut to say, does this value have an object key of the name val? Or of the name?
Oh, okay. And if not, then it's a number.
Yeah, else val.age. And val.name won't be there. So it's basically a way of, this is what's called a union type, where you have a union of possible members of that type. And it's a way of separating different objects and saying, okay, this one has a name. That means I can infer that it's this type.
All right, let's do one more question here. Can you explain keys of?
Yes,
Matt?
I can explain key of for sure. So key of is fairly simple. If we have an interface which is like A, which is a string, or interface letters, let's say. We have A, which is a string, B, which is a string, C, which is a string. We just saw the union type just before. It kind of looks like this, which is like type letters as union equals A or B or C. And this is basically saying this will accept either A, B, or C. So I can say const letter is letters as union, and this gives it its type. And now I can say it's either A or B or C. It's not going to be anything else than that. But I could express this in a different way by saying I want to just get the types of all of the keys here. So it could be A or B or C. And you can just say key of letters. And you get the same results. So you get A or B or C.
Now, can you use the key of for iteration as well? Like for in key of to iterate over key value pairs?
Yeah. Oh, man. You can do all sorts of crazy stuff with this, like predictably. So let's imagine, because the immediate thing that comes to mind is you could say, I want to get the object values here. Let's say that the values are actually string, number, or name string. So you can say letters and then say key of letters. So this is now the letter values. And this is going to be either string or number or name string. So this sort of key of here, what happens with a union type is if we say A or B here, when you use a union type in a property access, it automatically loops over it. So you say, okay, A, I want letters A or B, and I want their values. And what you get is string or number, because that's A and B up there. So if I say instead C or A, then it's going to be number or name string. So yeah, it's kind of, anytime you see one of these like union types, it's like any of these possible values, then what happens is they distribute, they kind of expand themselves out. And so you can have like, that you basically, any property access you do with it or various other things that you do, it will return a union of all of those types. It's kind of wild.
Man, I mean, this is awesome, but it's stressing my brain, man. I feel like I'm working really hard over here. Yeah, Eric, I'm with you. I agree.
Yep.
This comment is just how I feel about this whole stream right now.
Totally.
All right, let's do number 4, Matt.
All right, sounds good. Well, do we want to? How many more do we want to do? Because we could get to the really, really crazy stuff if you like.
What do you want, chat? You want to keep going?
What do you think?
Crazy?
Or like,
yeah.
Well, why don't I blow your mind and then you'll see how, like, if your brains explode, then we can.
Oh my gosh, I'm already out. I'm done.
So okay, this is nuts. I didn't want to code this live because it's pretty complex. But what's going on here is we're taking a search param, which is like, we're just taking this little bit and we're trying to turn it into an object down here. So what we're trying to do is say, okay, let's imagine that we have name equals Burke, and then profession equals chat beta. Then we have down here, we can say name, Burke, profession, chat beta, which is kind of crazy. And let me walk you through this piece by piece. Here, this like query here, we want to turn that into a type because currently it's just like a value. Get rid of my Git notifications. And so we first of all say type of on it, which turns it into a query here. We then, there's this little library called TS Toolbelt, which is insanely useful. And we basically get the string kind of object or namespace from it. And we say string.split, and we split the query at this point here. And then we access the second part of it. So the second query part is this name, Burke, profession, chat beta. Then we split it again. And you might have done this if you've ever sort of like tried to write your own search param parser. And suddenly the query elements, we have name, Burke, and profession here. So how are you with me so far? Does this make sense? Like we've reached this point by just splitting the string a couple of times. And we've got this little bit, basically.
Yeah, it's like URL parameters. Yeah.
Exactly. Yeah, it's URL params. And then here, what we do is we do some crazy stuff. And I'm kind of like, we take for each query element, because we've got like a little array of query elements now, we split the string again, and we basically take the first part of the string before the equals. That's what this little 0 is doing. Then we split it again, and we take the second bit. And so this essentially builds an object, because you can see the object syntax there. It builds it out of the query elements here. So we get a key of name and a value of Burke, and then profession chat beta. And then we map over it again with the query element. So this is really, really crazy stuff.
Okay, hold on.
Yeah.
So you have this head query params.
Yep.
The first part of that is going to give you the key on the left-hand side of the equals. And the right part of it, the second split, is going to give you the right-hand side of the equals.
Exactly.
And then the query elements number is going to give you which one of those key value pairs in the array of key value pairs that you have do you want. Do I understand that correctly?
I think you're with me, yeah.
All right. Dude, I feel extremely smart right now.
This is really hardcore stuff. Like, so, okay, let me just grab this out for you and like pull it out. So you can see that query string, like I'm grabbing query elements 1, and it's basically, this is saying for each query element in the query elements. So this is currently of length 2, and so I'm just grabbing the first one. So the key here is name, and then the value is Burke, which is from there. And so what this does is it basically, like, if we just replace this with name, key in name, and I think actually I noticed in chat this was someone's question from before. This was the in syntax they were referring to. This is saying for each key in this union of just name, I'm going to return Burke. So what this does then is we end up with an object which just has Burke in it, name Burke. I can change that. So this, if I then replace these, we're then grabbing all of the values for each query elements, and then grabbing all of the keys as well. And then so that's turned that into an object, and then we then, oh man. So if I don't return this, and I just have query params, this is now an object with the key here and the part of the object that we need to claim. And this is like the really crazy stuff. So I then map over that with query elements number, and we end up with a union of the possible keys with their values attached. And then we merge that union in, and we end up with our entire object. So this is like a single CSS div or something, like this is some crazy, just like playing around with stuff, but it really illustrates like what TypeScript can do when you take it to its advanced crazy level.
Okay, so get rid of this quick fix.
Yeah.
Okay, so on the query elements, could you select query elements by key instead of by number?
You could do, yeah. Because it's like a tuple, basically. It's not really an object, it's just like you can select it by 0 or select it by 1.
Right.
So if I don't do this mapping on the end, you end up with this shape here. And what I'm doing really is I'm just like taking all of the query elements, which are these keys, and just remapping over them to get the values. So type query.
I mean,
values?
how that even works is outside of my mind. Yeah, fictive. I'm with you.
This is wild stuff.
Like, how did you even know to do that?
So it's like, because here, if you just take like, it's you've got to break down each individual bit of it and know how all the flow fits together, you know. So here, like, if we just have name equals Burke, or what is it, profession equals chat beta, it's going to do the same thing, right? But it's just so happens that if I just replace all the bits here too with it, this happens to work too, and we still get our object at the end of the day. So it's all about just knowing all of the individual bits and how they fit together.
How they fit together.
And what their values are at any given time, and all of this like mad syntax, and yeah, getting it all working together.
Patrick's now going to decline the job offer. TypeScript developer. Yeah. Oh man. And I was watching this guitar, one of these like finger picking guitar YouTube videos, and Alexi, somebody, I forget his name. Anyway, it's so good, right? He's doing some cover of like Aha or something, and the top comment is, "My guitar just got up and walked out of the That's how I feel right now, right? Like my computer just left and is like, I quit, I'm out.
Yeah.
All right.
I mean, this is like someone showing you how they did the CSS single div challenge. You know, like it's so intricate, and it's so like, you know, this is why it's 10th on our list. You know, this is the hardcore stuff.
This is it. All right, Matt, we're about at an hour here. I feel like we could probably go all day and just keep doing this. Chat, should we have Matt back to do more TypeScript? I almost wonder if we need like a common TypeScript questions answered. Like when do I use this is a great question that I feel like nobody will answer, although you did here. Another one is like the whole API, right? Like, do I need to make that into a type? How do I do that? Yeah, definitely.
Totally. Yep. I'd love to answer all your questions.
All right, Matt, now's your time for a shameless plug. What do you want to tell people? What do you want people to know?
Well, I've got this advanced TypeScript course coming out, so you helped with that already. I'm also a developer advocate for Stately, and at Stately we do these really, really cool stuff, especially with VS Code, and I would love to come back and talk about that as well. One of the really, really cool things we're doing is we're building a visual editor for state machines, which allows you to just build loads and loads of cool stuff from right within VS Code. So I'm just signing into it now. Probably should have done this earlier. And this little machine here, we can actually like build this up and make it like edit it visually, which is kind of crazy. I'm just going to try this one more time to make sure it's working. There we go. So we get this little machine here. We can add states to it. Like this is all within VS Code, and this is kind of what I'm working on as a job at the moment, and working on with a bunch of other incredibly smart TypeScript colleagues as well. So I would love to come back and talk about this as well. Or chat, you can have a look at that at stately.ai/editor. So it's right there on our website.
And somebody did ask about your Twitter handle, which we'll throw up because I believe you do tweet frequently about TypeScript. So if you would like to have your mind blown on a regular basis, this is where you got to do that. Matt, thank you so much. I mean, I can't thank you enough for coming and sharing that with us. I feel like people who were lucky enough to be here, that was crazy and free.
Thank you so much, guys. I'm really, I love teaching this stuff, and I love learning more about it. So if you have any type challenges or things you want me to look at, or anything like that, then please tweet at me. I'm always on Twitter.
Well, thank you so much. Chat, would you please give Matt a hearty thank you for being with us today. We're honored to have you. You are the Rodney Mullen of TypeScript. Everybody, y'all know who Rodney Mullen is? We had this debate about, do people know who this is? Y'all know who Rodney Mullen is? No? Yeah? Do we need a different analogy?
Yeah, I don't know. Like I'm landing TypeScript tricks or something. I think we know the skate terminology, to be honest.
You should just be the Tony Hawk of TypeScript.
Yeah,
Why
sure.
aren't you just the Tony? All right. Thank you so much, Matt. Thank you, chat. We'll see you back here next week, where we will try really hard to follow up on this stream. It's going to be tough, but we're going to give it a shot. Thanks, everybody.